In this video, I want to look at some examples with multiplying and factoring with rational exponents. So in this first example here, you see z to the 2/3 power times z to the 1/3 minus z to the 5th. And we have parentheses. So we're going to use our regular multiplication technique here and go ahead and distribute that through. Now, I'm actually going to write out the intermediary steps this time because it's not something that I can as easily do in my head as in past examples. So in the first case, you have z to the 2/3, and you're multiplying that with z to the 1/3. And then you have a minus sign, z to the 2/3 times z to the 5th power. Now you're going to need to use your exponent rules next. So what's happening here is you're multiplying. So each of these has its own base, right? They're the same base, both z, and we're multiplying. So the rule there is that you add the exponents. Now, if you find it easier, you may want to just do it off to the side. 2/3 and 1/3 would be 3/3, which is just 1. So this piece right here becomes z to the 1st power, or just z. Now, in the second case, I'm looking at, again, the same thing. I'm multiplying. They each have their own base, so I'm going to add the exponents. And here I have 2/3 plus 5, which is 5/1. I definitely need common denominators, but I don't have them here. So I'm going to have to multiply the second fraction by 3/3. And I end up with 2/3 plus 15/3. So I get 17/3. And this becomes z to the 17/3. Now for us, this is as far as we're going to go here. This would be our solution. So we're leaving our answer as rational exponents in this case. If you needed to, you could change this over to radical form, right? You'd have a cube root here with the 17th power. And we could simplify that a little bit more. But at this point, we can just leave it with our rational exponents for this example. For the next one, I have two binomials I'm multiplying. So you want to think about either the FOIL method here or distributing twice. So I'm going to take the x to the 1/3 and bring it to both pieces in the second group. And then that minus 5 also to both pieces. Again, I'm going to write out the intermediary steps here because it's a bit tricky. So I have x to the 1/3 times x to the 1/3 plus x to the 1/3 times 2. On the inside, minus 5 times x to the 1/3, and then minus 5 times positive 2. Again, I'm multiplying here, so I'm actually going to add those exponents. Now, because they're already common denominators, I can do this pretty quickly. 1/3 and 1/3 is going to be 2/3. In the next group, I just have a 2 being multiplied here, so I'm just going to write the 2 out front, 2x to the 1/3. Here I just have a 5 being multiplied, so negative 5x to the 1/3. And there I have a 10. 5 times 2 is 10. Now, the last thing I can actually do here is I can combine my middle terms, and that's because they both have the same kind of variable. They both have x to the 1/3 as their variable, so they're like terms. So this becomes x to the 2/3 minus 3x to the 1/3 minus 10. And again, I'm just going to leave it in rational form for now. You could convert over to radicals if you wanted to, and these would both be a form of a cubed root in this case, but we can leave it as rationals for this problem. I also want to talk to you a little about factoring. So we're just going to do basic factoring here with rational exponents because it is pretty tricky. So we do want to factor x to the -1/2 from the following expression. So what you can do is just take your time with it. So I want to take x to the -1/2 and I want to factor it out, right? So I want to remove it. So I'm going to do it with an intermediary step first. And I'm going to think about sort of what would be left over in each case. So here, if I were to take out the -1/2 for the x piece, then I would have just a 3 left. So that one's pretty straightforward, right? It's just 3 and then the x to the -1/2. In the second case, though, I have a 7 here. And I definitely have something with the x left over. So here's where it gets tricky. So you want to actually do a little bit of trial and error and say to yourself, well, x to the what power So this number and this number here, when I take -1/2 and I add it to that number, I want to get the original 5/2 back out. So it's a little bit of trial and error. It's not like our standard factoring that we're used to. So what I'm factoring out, I'm writing here. And then I'm basically looking at the X piece and I say, okay, what would go here to make this actually work, right? I want -1/2 plus this to be 5/2. And what would have to work there would be 6/2, right? Because -1 plus 6 would be 5. So my question mark is going to be 6/2 in this case. That's the exponent that I'm going to go ahead and put in on the X. So you want to think of it, you can think of it like a subtraction problem or an addition problem, but something in that realm to say, okay, well, what am I missing to get this to work? And then what you would do is you would write that X to the -1/2 outside like we normally do. And what's left over? I have a 3 there, a minus 7X. Now 6/2 is also the same thing as 3, right? Because 6 over 2 is 3. So this becomes 7X to the 3rd power. And again, this is all we're going to do here. Let's do another one. So factor -1/5 from the expression. Again, I'm going to do it in a few steps here. So I'm going to start by writing that -1/5 first here. And then think about, well, okay, what's left over? Now, in the first case, because X to the -1/5 is already being taken out, I only have a 2 left. So that's the easier case. In the second position, I have a 7 left. And the X's are not the same. So there's going to be something left over there. So it's X to some power. And again, you're asking yourself, well, when I add these together, what would get me to 4/5, right? Well, the thing that would get me to 4/5 would be if I put this as 5/5, right? -1 plus 5 would be 4. So that's what's going to go here for my power. Now, notice that 5/5 is actually the same thing as 1. So this is X to the 1st power. So X to the -1/5 multiplied by 2 minus 7X. And again, this would be just the 1st power there, and that would just be X. So when we do this for rational expressions, it's very, very tricky. We're just kind of sort of taking it out almost like a GCF style here. But you really have to think carefully about, well, what would be the power left over? It's not as straightforward. So take your time with that piece. Think of it like a puzzle if you need to. That's sort of how I think of it. And then you can always check as well. So you can check by multiplying back through here and making sure this works. And don't forget, when you multiply back through, you're adding your powers. So you'd be adding -1/5, and this power of 1 would change to 5/5 to do common denominator. So it would actually check out.